Welcome dear students. Let us discuss regarding some of the anti-bloom agents, some anti-staling agents and anti-spattering agents used in food industry. Your favorite chocolate should look very good without any white specks. So we need anti-bloom agents there to avoid a defect called blooming in chocolates, very prominent in chocolates available in the market. Anti-staling for breads and bakery products, where the product tends to become dry and thus its shelf life is retarded, while anti-spattering to reduce the spattering of oils coming out from the frying pan. Let us see in this chapter about these ingredients. We'll first of all start with anti-blooming ingredients. What are anti-blooming ingredients? You all might be liking your good brown colored chocolate, very tempting, but whenever some white specks appear on top of these chocolates, you can see how ugly they look. So we need to add something that will actually avoid this kind of situation in chocolates, and especially when you are ready to eat them and you don't like looking at them. For this, we need anti-blooming ingredients. Now, what is blooming in chocolates? We'll discuss this first so that we'll understand what is the requirement of anti-blooming ingredients in these chocolates. A bloomed chocolate is characterized by the loss of initial gloss of surface, giving rise to more or less white specks. So as discussed, the beautiful chocolate now is filled with white specks, which is not liked by the consumer, and the appeal of the chocolate is reduced. The bloom appearance is, it is uniformly dull gray to a marble aspect. Some individual white points to a large white spots on the chocolates can be observed. Thus, the appearance is masked and the beauty of the chocolate is reduced. Now, what are these blooms actually? These blooms are not injurious, or they are not actually defects. It is a appearance defect, it is a visual defects, and it can be because of fat or can be because of sugar. Hence, we can divide or we can bifurcate these blooms into two types. One is fat bloom and the second is sugar bloom. Now, why these blooms appear? You should know the causes of this bloom, and it is a very common phenomenon in chocolates. The causes may be again classified because it may be due to composition, may be due to processing and storage conditions. So what is the effect of composition? First and the foremost thing is because of incompatible fats. A chocolate may contain not one, maybe two or different types of fats mixed together to give a particular taste. Now, if these fats mix are not compatible to each other, so they are not mixed properly, and one or the other fat tends to come out on surface of the product, giving you a bloom appearance. The second compositional effect is as in filled chocolates, where the interior or the center is rich in oil content. The center is very much rich in oil content, while the surrounding is containing less oil. Again, there is variation in the concentration of oil. As a result, because of mass balancing, the oil may come out into the less oil section and come on the surface to show you a bloom on the chocolate surfaces. So the concentration at which the two fats separate determines the limits of solubility, and below this concentration the fats are compatible, but above this concentration they are incompatible and tend to separate. So as I discussed, there might be some proper concentration of both the fats, one or more fats which are added together, so that they get solubilized or mixed into each other with proper emulsification, with emulsifiers added. If the concentration of either of the fat is above this limit, the solubility is reduced. As a result, they become incompatible and they tend to separate out in form of blooms on the surface of chocolates. Next cause, as I said, is a process effect. Tempering is one of the very important process giving desirable body and texture in chocolates. It is a smoothing effect. If the chocolate is not properly tempered, you may not get the desirable body and texture, and uniformity in chocolate and their products. Even over or under tempering may hasten blooming, giving you uneven white colored surface. After tempering, cooling process is also important. Fast rate of cooling or improper cooling systems may affect this bloom effect and cause blooming on chocolate surface. The other factor is storage condition. Both temperature and temperature fluctuations affect bloom during storage. Because of temperature fluctuations, the stability of fats and other ingredients in the chocolate are disturbed. Because of destabilization of this compositional ingredients in chocolates, the ingredients may separate out, especially fats tend to separate out and come on the surface. Because at higher temperature, the fats are in liquid form, while at lower temperature, they usually are in solid form. So if the temperature fluctuates, higher the temperature, they get converted into liquid form, they separate out easily, and when again lower temperature is achieved, they form white specks on surface of the chocolates. So high temperature and then cooling will definitely give you blooms in a chocolate. Now, what kind of anti-bloom ingredients we can add? So we can have some kind of variation in the fat fractions itself, as for example, using high melting fraction with high SOS in cocoa butter will give you lesser bloom in chocolates. The vegetable fats that are added, again, the bloom rate is inversely correlated to solid fat content of the fat as such. So higher the solid fat content, more is the chance of bloom. So rate of blooming will decrease with reduction in solid fat content. Milk fat, again hydrogenated, that is high melting milk fat fractions are more affected. Emulsifiers like lecithin, span, twin can be used for chocolates for better emulsification of these fats so that they don't separate out. You can also use other emulsifiers like mono and diglycerides, monoglycosyl diglyceride and sucrose fatty acid esters for compound chocolates. Compound chocolates are having more number of ingredients, more different types of fats and different forms of ingredients. As a result, more strong emulsifiers are needed in these types of chocolates. You also have special compounds like pristine, 1,3-oleoyl, 2-steroyl glycerol and also sugar particles which can help as anti-blooming ingredients. The main aspect here is you should use such kind of ingredients which will not easily melt when higher temperatures are achieved, and again during cooling they should not form blooms. So to control this, if you are using high melting fractions, so even during temperature fluctuations there will be lesser chances of these fat fractions to melt and come on surface and further become blooms during cooling process. As well as proper emulsification, we'll see that these fats does not get separated. Now we'll discuss regarding anti-staling ingredients. Now what is anti-staling ingredients? It's very important, especially if you see products like bread and other bakery products. Breads usually you see after a few days tend to get hardened. Initially it is very soft, very fluffy, but with time it is getting hardened, it is getting tough, which is again not liked, and it may again break down as a brittle material. The taste may be good, but if the body and texture of bread is not soft, you will not like it. So this is a process which is due to staling of these products, and we need anti-staling ingredients which can extend the shelf life of such kind of products. Staling or going stale is a chemical and physical process in bread and other foods that reduces their palatability. As I discussed earlier, stale bread is dry and leathery, and staling most rapid at temperatures just above freezing. So enriched breads usually has shelf lives of about 5 days or less because of this staling process. High sugar and fat products tend to stale at a slower rate, but the products containing lesser sugar and with low fat will stale early, and nowadays, because of health issues, people are tending to use low sugar products as well as low fat products. So here the chances of staling increases and the shelf life of the products will tend to reduce in bakery products, especially breads. Let us first understand the staling mechanism. It is the migration of moisture from the starch granules into the interstitial spaces, degelatinizing the starch. The starch amylose and amylopectin molecules realign themselves, causing recrystallization. As a result, it gets converted into stale bread's leathery and hard texture. The pleasant, fresh flavor is also lost into the air, and often unpleasant flavor is absorbed. Because the product becomes dry, it is not soft now, the good pleasantness, fresh flavor is going out, and it may absorb some other off flavor which is not desirable, and it cannot be consumed by the consumer. So let us see the anti-staling ingredients. One is enzymes, that may be, the examples are bacterial amylases and lipases. The next anti-staling ingredient are pentosans, which are highly hydrophilic and have similar properties to that of vegetable gums. As a result, what they will do, they will retain moisture into the product, they will not allow the moisture to evaporate, thus extending the shelf life of the product, keeping the product softer for a longer period. Similar effect is given by even hydrocolloids, and the concentrations of around 0.1% gives anti-staling effects in case of hydrochlorides, which acts in a similar manner. It absorbs moisture, retains moisture in the product, and thus extends the shelf life of the product, making it suitable to be consumed for a longer period. Even polydextrose can be used as anti-staling ingredients because they are highly hygroscopic and they also delay staling in the same manner. Others are surface active lipids, emulsifiers, and crumb softeners, which will produce soft type breads. Then you can use 10% waxy wheat flour, but it gives very minor effect because it is containing higher monoglyceride effect. So the softening effect is increased, but the effect observed to be is very minor. Quite often, when we go for cooking, especially taking oil in a pan, you find some spattering effect out of the pan. It makes a lot of noise, and sometimes the oil comes out and comes onto your body or your face, and it is thus injurious to you. This thing can be termed as spattering effect. So this is because of water coming in contact with oil, and when they get heated, the water tends to evaporate, come out, and while coming out in form of vapor, it brings some oil into it, which is at higher temperature and may cause harmful effect into the body. Here we need some anti-spattering ingredients. So in oils, where the chances of water coming into them during cooking are more, we have to add anti-spattering ingredients so the spattering effect are reduced during cooking. Now, what is spattering? As I told you, during frying, when foods are introduced in the hot oil, the water contained in the food is instantaneously evaporated. The water evaporated carries oil and food particles, which may entail possible burns by the user. Oil and food wastes also are there because of it, and soiling of the frying area has been observed many times, and this is what we say is spattering. Lecithin, sucrose esters of fatty acids, and sodium sulfoacetate derivatives of mono and diglycerides are added to oils and fats to prevent potentially dangerous spattering effects. Now we'll understand the spattering mechanism. When the food is placed in oil, the humidity reacts. Obviously, if water is present or humidity in oil is present, it will react. It will tend to evaporate fast because the boiling point of that water portion has been achieved. Hence, it evaporates immediately. The vapor generated gets in contact with the oil, Now both interact as a result of an interfacial force. In this way, when the vapor column goes out, a certain amount of oil remains linked to the vapor. This causes frying spattering. Again, this spattering can be classified into two types. One is primary spattering and the second is secondary spattering. Primary spattering occurs when spread is heated to drive off the water phase, while secondary spattering occurs when water is added to the hot fat. So removal of moisture from the fat source itself is a primary spattering mechanism, as for example if you heat butter, if you heat spread, if you heat margarine, while when the fat or 100% oil comes in contact with water, they are heated, it is secondary spattering. Anti-spattering ingredients. The anti-spattering agents include nitrogen, salt, calcium chloride or even phosphates, and emulsifiers such as egg yolk and lecithin. We want the fat and the liquid to interact in such a manner that they don't form spatters during cooking because of rise in temperature. So we can use some emulsifiers that can mix these two things and cause lesser spattering effect during cooking. Now some reported examples are listed, like mixture of partially oxidized soybean oil, which is a source of phosphatides, and salt to be used in spreadable oils. Now water in oil emulsion containing a porous vegetable material where particle size is 1 to 2000 micrometer. One more example of anti-spattering agent used is mixture of anti-spattering emulsifier agents like hydrolyzed lecithin, fractioned lecithin, citric acid esters and their mixtures. And one more example where anti-spattering ingredients have been used is a phosphatide and a metal hydrophilic oxide and or slightly divided metal oxide, and it has been used successfully in case of margarine. Now how does these anti-spattering agents work? The principles, let us discuss. These anti-spattering ingredients function by preventing the coalescence of water droplets. So water droplets are separated. As a result, small spatters may come out. The large spatters that may cause larger injury and bigger problems are avoided. Second effect may be, it alters the interfacial activity of oils among the gaseous phase, that is the vapor, the liquid phase, that is the oil, and the solid phase, that is the food. Because this is the reason why spattering occurs. So it alters that interfacial activity. As a result, the spattering effect is reduced. One more effect could be, water evaporated releases more easily from the oil, and the vapor column formed does not carry very high quantity of oil. So it can act in such a manner that it removes only the water portion in form of vapor and not the oil coming along with this vapor, which may cause injury as a result of spattering. So to conclude, I may say that blooming in chocolate is a burning issue. Even the big brands are finding suitable solutions to these blooming problems in chocolates, which sometimes becomes unavoidable. And the main reason is that the exact mechanism is still a mystery. There can be a number of possible reasons for blooming in chocolates. It can be because of the processing, because of the composition, because of the storage effect. And sometimes few of the things are not in our hands. And also, we can use here anti-blooming agents to control this blooming effect and their combinations, which can be very effectively used to delay blooming in such kind of chocolates. Chocolate being a very big industry and a very appealing product, a very tempting product, we need to have something that will increase its appeal and reduce such kind of blooms in the product. We also talked about staling, which is a physicochemical reactions of the amylopectin fraction of the starch components. So it is affected by processing, formulation, storage conditions, and one thing that is purely in our hand is addition of these anti-staling ingredients as additives, which can retard staling in these products. Lipid surfactants and enzymes are more beneficial as anti-staling ingredients. Now, anti-spattering ingredients in fats and oils are important to prevent any minor or major accidents. Sometimes it looks minor, but it can also give a major accident, as for example, if the spatters comes into the contact of your eyes, it may damage the retina and cause serious injury to you. But yes, as in all food additives, the legal issues are needed to be addressed. So we have discussed in length regarding the secret for getting good appeared chocolates, which is more tempting in nature with lesser white specks by using anti-blooming ingredients. Also, we have seen breads should be soft and we have to add anti-staling agents to increase its shelf life to get a good soft fluffy bread for a longer period. And finally, we have seen some spattering things that is coming out of the cooking pan or frying pan, and it may injure us, and hence the anti-spattering agents are important for this regard. But the ingredients added should be in limit and should be properly used. Thank you.